Hello there. In this video, we're going to talk about order of operations. And on my page here, I've written out a problem that is actually quite famous. If you search order of operations memes on Google, this problem will come up, and it comes out to two different answers that people often debate over: 1 and 9. And by the end of the video, you will understand why we have the answer that we have. I'm not going to spoil it though. More than that, we're going to look at why order of operations is the way it is. Why do we do multiplication before addition? Or why do we work with parentheses before anything else? So first off, to understand that, let's outline what order of operations is. Order of operations, most famously known as PEMDAS. This is parentheses, exponents, multiply, divide, add, and subtract. Now, it's important to know that the multiplication and division kind of come together as a pair. You always have to work these through left to right. Same for addition and subtraction. So sometimes what I will do as a teacher is I will write it out as P on top, E, and then M and D on the same line to remind us we don't know which one comes first, and then same for addition and subtraction. Now, if you search order of operations on Google, just do a quick Google search, there are alternatives to this form. There is BODMAS, and what we've done is change the B, P to a B, and we call it brackets, and then change the exponents to operators. Now, why do we do that? It's because parentheses don't just have to come in this form. They could come in this form. They could come in this form. Why do we change the E to an O? Well, this stands for operators. This could be x cubed, or it could be cube root of x. We could be dealing with a radical, or we could be dealing with a cube, or a fourth power. Now, this also goes to happen to show that we could be dealing with any kind of grouping. I mean, the radical itself is in its sense a grouping. If I had the cube root of 7 plus 1, I have to deal with this like it's a grouping and do 7 plus 1 before I do the cube root, which will give me a final answer of 2. Also, absolute values could count as a grouping. You have to work within the absolute value before you can bring anything from outside the absolute values. So this kind of leads me to a point of saying use whichever abbreviations work best for you. I'm going to work with PEMDAS mostly because that's the one I'm most familiar with. But keeping in the back of mind, parentheses just doesn't mean curly brackets. It could mean these. It could mean these. It could mean absolute value signs. It could mean something like this, where the numbers are inside a cube root. Exponents could also be cube roots, multiplying and dividing. We have to remember to deal with those left to right. Now, why does it turn out this way? To start that way, let's look at the expression 3 times 2 plus 1. To understand why order of operations comes out the way it is, we have to understand what these operations are. So really, let's just quickly look at 3 times 2. What does 3 times 2? Well, it means repeated addition. Multiplication is repeated addition. So this could mean, it's either going to mean 3 plus 3, or it's going to mean 2 plus 2 plus 2. Take whichever one. I mean, they both mean the same thing. They're both going to be equal to 6. So why is it a mistake when people say 3 times 2 plus 1? Oh, well, that's just 3 times 3. Well, because 3 times 3 is 9. But as we can see from this operations, I'm only repeating the addition of 2 or 3. If I roll this 1 into the 2, now I'm saying, okay, I'm repeating the number 3 times. And so instead I get, if I rewrite this as 2 plus 2 plus 2 plus 1, yeah, now I can most certainly do this first. I get 2 plus 2 plus 3, but notice I only did it to one of the 2's, and I get 4 plus 3, which gives us our actual answer of 7. So you have to do the repeated addition that comes first before you do anything else. What's more, why, if it's written out addition then subtraction, would we do subtraction first? Well, let's work it out the same way. Let's just cover this up and just say we're dealing with 4 plus 5. Well, that's 9. Well, that means if I did this first down here, I'd have 2 minus 9, which is negative 7. Remember what I said in my first mental math video, that subtracting is like adding the opposite. So I could rewrite this as 2 plus a negative 4 plus 5. So any subtraction can be turned into addition and vice versa. So if I now look at doing this addition first, 2 plus negative 4 is negative 2 plus 5. And that equals 3, which is the real answer. This is wrong. When we're dealing with a problem like this, I often tell you, you can do the addition first, but you have to treat that minus sign as though it's a negative, and you have to work through negative 4 plus 5, and that equals 1. And then you can do 2 plus 1 to give you 3. That's why we have to do the subtraction first, is because that 4 is basically a negative. And if we do the addition first, we're treating it as a positive. We can see that similar behavior in multiplication division. 4 divided by 2 times 3. If I wanted to go through this multiplication first, I'd get 4 divided by 6 is equal to 2/3. Well, this 4 divided by 2 that's here, if we rewrote that, that would be, as a division problem in fraction form, that would be like this. And so really what you're dealing with is not dealing with a 2, but you're really dealing with a 1/2 when you're dividing it. So it's the same as saying 4 times 1/2 times 3. When I say we can make any subtraction problem a division problem or an addition problem, we can make any division a multiplication problem. What I did here was just keep, change, flip what I did in my fractions video. So what this really turns out to be is 4 divided by 2, which is 2 times 3, which is 6, my final answer, and that is incorrect. So what's more is when we deal with, why do we deal with exponents before multiplication? Pretty much the same idea as why we deal with multiplication before addition. Say I had the problem 2 cubed times 3. We have to remember multiplication is repeated addition, but exponentiation is repeated multiplication. So this would be 2 times 2 times 2. To take the 2 times 3 before we take the exponent would be saying, okay, each 2 is getting multiplied by 3, when in reality, if I wanted to expand this and do that first, I'm only multiplying one of the 2's by 3. And so we have to deal with the repeated pattern before we deal with the little bit left over at the end. So 2 cubed is 8 times 3 is 24. And this is one where we can see a stark difference, where if we did the 2 times 3 first, we get 6 cubed, and that equals 216, which of course is incorrect. So let's end by going over that problem. 6 divided by 2 times 1 plus 2. And the two answers that were posed, and that are all usually posed in the memes, is it 1 or is it 9? So order of operations dictates I do my parentheses first. So that's the 1 plus 2. So 6, I'll write this, 6 divided by 2, and then this just becomes a multiplication. 1 plus 2 is 3. Multiplication and division is left. I have to work left to right. So 6 divided by 2 is 3 times 3, and I get 9, and there's your final answer. Let's do one more that has a little bit more to it. So I'm going to put the problem 1 minus 4 times the quantity 2 cubed plus 4. I'll write my order of operations off to the side. Okay, parentheses comes first, but within that parentheses is the exponent. So I have to do the exponent before the addition. Within parentheses, I still have to obey order of operations. So 1 minus 4 will get written out. 2 cubed is 8 plus 4. And now I can finish off the parentheses by doing the addition that is in the parentheses. 1 minus 4, 8 plus 4 is 12. So I'll just write it as times 12. And now when I see this problem, it's tempting for the students to want to go, okay, I want to do the 1 minus 4 first. No, multiplication comes next. And I can keep the 1 minus the same. 4 times 12 is 48. And then 1 minus 48 is negative 47. And that's it. Thanks for watching the video. If you would like to leave a comment about more video ideas, please do. Otherwise, hit that subscribe button, and I'll see you in the next video. Thank you. Maybe I'll want to try and finish.